Welcome once again, wonderful people, and this time we are on 1.2, and they say that we should show that 0.9 with a dot is equal to 1. And the dot just tells us that you have a few nines after the decimal. So let's just rewrite this with a minimum of 5 nines. So this, we will write 0.12345. And let's insert this on a calculator and see what value we will have. So on a calculator, I will say 0.59, and let me see the fractional value of this. Okay, I can't find the fractional value of this, but we can assume that 0.99, this would be let me check the value first to see that 1 2 3 4 5 divide by 10,000. Let me see what value I will find. No, this is not the value that I have. So let me come here and do this. Let me just have a point here and see what will transpire. It still doesn't work. So when you are given a problem of this nature, and we know that this 0.9 with a dot tells you to have several numbers, nines after the comma. So what we will say let this number that we are given to be x. So when we see 0.9, we will write x. So I'm going to say 0.9 with a head is equals to x. That's exactly what I'm going to say there. And once I have said that, I will say, okay, if this is equals to x and this must be equal to a whole number, how can I write 0.9 as a whole number? Now I can write this as a whole number by multiplying both left and right by 10. That's one possibility. So I can say, okay, I can write this. Remember, this is 0.9 with a dot. So I'm going to say 0.9 with a dot because I'm given two numbers. Therefore, I'm trying to convert this two number as a whole number because it's a decimal. That is why I'm multiplying by 10. So meaning I what I'm doing is I try to ignore these nines. I'm treating this as just two numbers. That is why I'm multiplying by 10. Because if I treated this as maybe 5 or 6 digits after the comma, then I will not be able to multiply by 10. There has to be a particular number that I will have to multiply with. But even though that this dot tells me that I have several nines after the comma, but because I'm provided with only two numbers, therefore I'm going to multiply by 10 irrespective of knowing that I have more than one number after the comma. So this is exactly how I look into this. Hence I'm multiplying both left and right by 10. So when I multiply by 10, one thing I know is that, okay, if I do that, what I'm going to have here, if you go to your calculator, for example, we have this, let me just make an example, 0.99, and I multiply 0.99 by 10, and this will give me a value of 9.9. So for example here, if I multiply by 10, I will find 9.9999. So this is exactly what I will get if I multiply by 10. And then by so doing, meaning I will have 9.9 still continuing. I know I have other several nines, and this will be equals to 10x. So this will be the second equation, of which the first one was multiplied by 10. And then secondly, what we do from here, whatever that is on the left, subtract whatever that is on the left from the first equation. Whatever that is on the right, subtract whatever that is on the right of your first equation. So meaning you will take this 9.9 with a dot, it will subtract 0.9 with a dot, and this will be 10x minus x. So bigger number left, subtracting left, bigger number right, subtracting the right. So this is exactly what we are doing, and you must be very careful here. I'm having 9.9 with a dot, showing that I still have 9s continuing. Even here I still have those 9 continuing in that order. And then from there you can just go to your calculator and say, okay, 9.9 or 9.999. if you take 4 9s after the comma, when you subtract 0 point, you must also subtract 4 9s from this side. Very good. And then when you do that, you will get exactly a whole number of 9. So 9 will be equals to 10x minus x, which is 9x. And then from there you divide by 9 and you get your x as being equals to 1. So this is how we prove that 0.9 with a dot is equal to 1. Okay, that's fine. That was the end of question 1. You only had 2 problems, and then we go to question 2. Alright, in question 2 they say we should factorize an expression. In 2.1 we have 3x squared plus 9x minus 2xy minus 6y, and we want to factorize this. Now factorization, okay, something is common here and something is also common there. I have a common factor of a number which is 3. I also have a common factor of a number which is x. Remember, you will always take the lowest. 3 goes into 9 without leaving a remainder, you will take 3. X goes into x squared without leaving a remainder, you will take x. You will open up your bracket, you will say I took out 3x here, but there were 2 x's, so only 1 is left. Addition sign, what number, or you will just say what number, okay, just say how many times does 3 goes into 9? 3 times. But because you took x, there it is, this is all that is left, because remember 3x times x is 9x. So the aim here is to create 2 brackets that are identical. There's a common factor here, I can take out minus 2, but there's also a y. Very good, open bracket, because 2 goes into 6 without leaving a remainder, y goes into y without leaving a remainder, and it's common on both. So here I took out 2y, I'm left with x. Now remember, this is negative and that is negative, so if this is negative, this has to be positive, so that negative times positive is a negative. How many times does 2 go into 6? 3 times. You already took y, there it is, then you close. We have created 2 brackets that are the same, so I can take out a common factor here of x plus 3. I will be left with 3x minus, I took out x plus 3 from this side, I'm left with 2y, and this is my factorization. Alright, in 2.2 we can continue and say simplify what is it that I'm simplifying? In 2.2.1, m squared minus 64 m squared plus 8m divided by m minus 8 all over m. And now, since I'm dealing with this, I know that this is a difference of two squares, m minus 8m plus 8. There's a common factor of m. M goes into m squared without leaving a remainder. I took 1m, 1 is left, plus I took 1m, 8 is left. I can change division to multiplication. You will take the reciprocal, you will have your m minus 8. Numerator, denominator goes once because there's multiplication. Numerator, denominator goes once because there's multiplication. Numerator, denominator goes once because there's multiplication, and the answer becomes 1. Some of the things that just requires one to revise and for one to understand exactly what is happening. Okay, be that as it may, we can move to 2.2.2. all right, so remember we are still simplifying. That one was a factorization. This one they said we should simplify. And I have 2 n minus 1, 8 n plus 1, 16 exponent n. And with this I can say, okay, there's nothing I can do, but I can write 8 as 2 exponent 3, which is being multiplied by n plus 1. 16, 2 exponent, I think maybe it's 5 exponent n. Let me just verify this by just going to my calculator and just saying 2 to the exponent of 5. No, so it has to be 4 here. Very good. Now that we are fine with this, what else follows after this? Now all we have to do is to apply the law of the exponents. When you multiply, you add, and when you divide, you subtract. So I will have to simplify first this, because this 3 has to multiply this and this. So I will have my 2, my n minus 1, my base of 2, 3 times n, 3n, 3 times 1, 3. And my 2, 4 times n, 4n. And from there I can apply the law. When I multiply, I add, because they are both on the numerator. You don't change any exponent. You just write one base. You write your n minus 1, and you are adding to your 3n plus 3. And because you are on the denominator, you just take the exponent and you subtract it, because it is going on top. N plus 3n, it's 4n minus 4n, this is 0. Minus 1 plus 3, it's 2. The answer becomes 4. And you are done. You are fully done when you have done that. Okay, assuming that we have both understood, let's now go to question 3. Now in question 3, let me read what the instructions are. Solve for the unknown variables in each of the following. Now There are certain strategic ways that we will have to employ in this. We're going to try and see different ways of approach and which ones are applicable and which ones are not, and where our algebra might have went wrong before we can do that which is right, because these are some of the mistakes that many students can do. So in 3.1 we have a plus 1 a squared plus 2a minus 3, that is equals to a squared plus 3a. Imagine something of this nature is provided, and all we have to know or to do is to solve for the variable. Now if I want to solve for the variable here, I will say, okay, I'm not going to apply the distributive law of multiplication on this. Why? Because I can take out a common factor in here and see what I can do. Because when I look at this, the question that comes is, can I factorize this? Can I find the factors of -3 that can give me 2? Let me try and see. A plus 1, a 3, 1. The bigger number takes the sign of the middle term, and when I multiply them I should get a negative. So if you are positive, you must be negative. Positive 3 times -1 is -3. 3 minus 1 is 2. So it can be factorized. And I will equate this to a. Now, once again, this can be factorized. And if I factorize that, I can take out a. Remember, I'm just in here. I can take out a and have a plus 3. Okay, this is fascinating stuff. And what is it that I can do from here? I know that the laws of multiplication, a times b times c, it's c b a, or even c a b, whatever the order is not important with multiplication. So I can divide by a plus 3, a plus 3, and this into this will go once. I'll be left with a plus 1, a minus 1. This and this is this. This will be equated to a times a, which is a squared. Very good. Okay, I will have to use distribution here. I don't have any choice. I'll have a squared, but this is a difference of two squares. A squared minus a plus a, they will cancel, minus 1 equals a squared. And immediately I'm confronted with a problem here. If you take this to the side, you'll get 0 equals 1, which is not possible. Okay, where did my algebra goes wrong? Was I wrong when I factor out an a here? No, I was never. Was I wrong when I factorized here? No, I was never. But now I seem impossible to find the values of a. Okay, after the first method had failed in the exam, I will copy the problem once again. Exactly as it was given. And this time I will say, all right, let me remove the brackets by multiplication. If I apply multiplication here, let me also apply multiplication there. It will force me, of course, to do that. Once I try to remove the brackets by multiplication on the right, I will have to also do it on the left. So that's fine. I'll find a 3 plus 2a squared minus 3a plus a squared plus 2a minus 3, and this will be equals to a 3 plus 3a squared. Okay, and if this is true, let me see if I can find any like terms. I have u, this and this will give me 3a squared. Let me just cancel these ones so that I don't make any mistake. Minus 3a plus 2a, it's minus a, and I have my minus 3, and immediately I take this to the other side, this to the other side, and I'm left with 0, and immediately this and this cancels one another, this and this cancels one another. Minus a equals to 3 if I take this to the other side, divide by minus 1 because there's a minus 1 there, minus 1 and minus 1 cancels, I'm left with a, and a is minus 3. So there seems to be a better way of finding this. So those might be several approaches that many of us might try and see what answer they will provide to us. Okay, now let's go to the second one. Many of these problems are not that difficult. Solve for the unknown variable. So we have 2x squared plus x minus 3 being equals to 0. Of course, what I will do, because the coefficient of x squared is 2, I'm not going to use a quadratic here. You take this number 2 and you multiply a constant with that number. You are removing this number and you are multiplying here. So what I'm saying is you write this as x squared plus x, and then you say 2 times negative 3, it gives you negative 6, and you equate this to 0. Can you find the factors of 6 that can give you 1? Yes, that's 3 and 2. The bigger number takes the sign of the middle term. When you multiply them, you should get a negative, and then that 2 which you multiplied here with, you divide every integer with that 2. Now, because 2 goes into 3 leaving a remainder, you don't divide. You take this 2, you multiply that x with this 2. You'll have your 2x plus 3. Because you multiplied here, you no longer have a 2 here, you only left with a 3. Now, in here you have your x. 2 goes into 2 without leaving a remainder, yes. And this is how you factorize this. Very, very important. Now we can solve. When you have these numbers which are multiplying one another and they are equals to 0, you don't remove the brackets here. You say the first bracket equals 0, or the second bracket equals to 0. Take to the other side, and here you divide by 2, you will get negative 3.5, or x is equals to 1. This is how you should do it. I know that you understand. You just require more time to sit down and practice, which is something that I believe that you will do. And when we are done with that, I want us to look at an inequality problem here that says 3. Let me just do this. We have an inequality problem that says 3 should be less or equals to 2x, and what else? 2x minus 1, which is less than 7. So this is what we have, and this is what we need to solve. Now, Where you have two inequalities at the same time, the first thing you do, you concentrate first on this one. 3 less or equals to 2x minus 1. Solve this. Take to the other side. 3 plus 1, this will be 4. And you can divide by 2, having your x as bigger or equals to 2. The first solution. Secondly, you concentrate on this. 2x minus 1 being less than 7. Take to the other side. Divide by 2, x being less than 4. You draw up your number line. You have your x. You are saying you can have your 2 and your 4, because 2 is smaller than 4. So x, which is x must be bigger or equals to 2. So here you are at 2. Because it says bigger or equals to 2, we will shade. X must be bigger or equals to 2. All those numbers going to that side, they are bigger or equals to 2. And then x should be smaller than 4. Open, because there's no equal, you just open and not shade. Values that are less than 4, all those values go in that side. Where is the intersection? Here it is, where the solution is. So you will just say this. Remember, x should be greater or equals to 2 and x should be less than 4. Very, very important that we understand this. So that becomes a solution to this problem. I hope this has become very, very clear. Okay. Now, before we wrap up question 3, let's go to simultaneous equation. So in simultaneous, this is what we have. Where is it? We have 3 x plus y. This is 27 squared. And the second one, it's 2y equals 4x plus 1. So this is simultaneous because you are always given two equations. They can be very complicated. They can be in simplicity, as you can see. So I will say that this is 1 and this is 2. And I can take, remember, in simultaneous equation, you look for one equation where it's easier to make x or y the subject of the formula. So I think in both it's very simple, because I can take 2, I can say from 2, I write down equation 2. Then I can change the base to be 2 here. I can remove the brackets by multiplication. 2x plus 2 if I multiply like this. And then when the bases are the same, you equate the exponent. Now this is what I name as equation 3. It's an equation where I was able to make y the subject of the formula. So it is this equation that I'm going to substitute into equation 1, which is an equation that I haven't yet worked with. So you say I will substitute 3 in 1. You first write down 1. Now where you see y in this equation, write this. So I have my 3, I have my x plus, I see y, and immediately I write 2x plus 2, that is equals to 27. I can write as 3 squared. 27, it's 3, but it is squared. I can group the like terms. X plus 2x is 3x plus 2. There's 2, remember. and this is 3, 6, because 3 times 2 is 6. And the bases are the same, I can equate. 3x plus 2, this is 6. 3x, it's 8. And then my x is 8 over 3. And this is my equation 4. And I can substitute 4 in 3. You'll always substitute in 3. Write down 3. Y equals 2x plus 2. And then from here, where you see x, write 8 over 3. You will have your 2 into 8 over 3 plus 2. This will be 16 over 3 plus 2, giving you a value. Let me go to the calculator very quickly. We have 16 over 3 plus 2, and you'll find a value of 22 over 3 as your value of y. So you have your x and your y. You are fine. You can substitute on any of these equations, and the left will always be equals to the right. So when all that is done, what is it that we can do? Let me check. I think I've made a mistake. I'm very sorry. I think I've made a mistake. 6 minus 2. 6 minus 2 will give you 4. I'm very sorry. This is 4, so meaning this will be 4/3. I'm very sorry, please. This is 4. I'm very sorry, I made a mistake. This becomes 8 over 3 plus 2. I'm very sorry, wonderful people. I'm very sorry, I made a mistake. Let me just quickly go to the calculator and say 8 and find 14 over 3. I'm very sorry, I made a mistake. This was supposed to be 6 minus 2, which is 4, not 6 plus 2, which is 8. I'm very sorry for that lousy mistake. Right, that was the end of question 3, and I think I will see you in question 4.